This video is about aspects of a function. So we are going to recognize and identify local min and maxes on a graph. We're also going to determine what happens to a graph as x approaches a particular value. So first let's talk about what a local min and a local max are. So a local maximum is a point that is higher than all your other points. So right here is a local maximum. So a local maximum, think about it looking like a hill or a mountain. A local minimum is a point which is lower than all other points. So here is an example of a local minimum. And a local minimum would look like a valley. Sometimes graphs will only have a local max or a local min. Sometimes they will have both, and sometimes they will have neither. These points are called a vertex. So let's look at the graphs and figure out if we have local min, local max, or both. So in the first graph, we have a high point. So this would be a local max. We also have a low point, which would be my local min. So in this case, our graph has both. In number 2, I only have a high point, which would be a maximum. So in this case, we only have a local maximum. In number 3, we have 3 high points. 1, 2, 3. These are all called local maximums because they're the highest part for that point of the graph, but they might not be the highest overall since there's 3 of them. We also have 2 local mins because they're the lowest part of their graph, but they might not be the lowest overall. So in this case, we again have both. In number 4, we only have a low point here, which is a minimum, so we would only have a local min. So let's use this idea to look at a graph and identify the local min and max. So number 5, we're going to use the graph to answer the following questions. Is point A local max or min? So if I look at point A up here, point A is a higher point compared to other parts on the graph. So this is a local max. What are the coordinates of it? So we're going to look at our x, y coordinate to see what lines up. So the x coordinate's 4, the y coordinate's 6. Remember, coordinates are always written x comma y. So our point would be 4, 6. When we look at point B is a lower point on the graph. And because it's a lower point, that is going to be a minimum. When I look at my coordinate, my x is -5, my y is -2. So the point would be -5, -2. Another aspect of a function is called an interval. So an interval is a specific part of the function given two endpoints. So when I look at a function, I'm going to be given two endpoints that I would follow my graph on. When it says -infinity, you want to look at the left arrow on your graph. So we're going to move from the left arrow all the way to where we get to be even with 0 on my x-axis. So remember, this is our x-axis and here is 0, so I would stop my graph there. This is interval A. Interval B is going to go from 0, so where we just stopped, all the way to the x value of 5 where our graph is. This is our second interval B. The last interval then goes from 5 to infinity. Remember that infinity is your right arrow. So we go from 5 to our positive infinity. This then is our C interval. So along an interval, you can do two things. You can increase or decrease. If you traveled up to trace your function, that means the function is increasing. So in this case, when we traced our function for A, we went up along the graph, and for C, we went up along the graph. So in this case, A and C were both increasing. If you travel downward, then the function is decreasing. So when we traced B from 0 to 5, we went down along our graph, which means that that would be decreasing for interval B. So let's look at a graph and identify if it's increasing or decreasing along the interval. So the first interval that we are given is negative infinity to negative 2. So remember, negative infinity is our left arrow. So as I trace my graph to get to negative 2, I move down along the graph, which means that my graph is decreasing. The next interval is from negative 2 to 1. So from negative 2 to 1, I went up while tracing my graph, which means that I am increasing. My third interval from 1 to 7, I'm going down along the graph, which means that I am decreasing. And then for my last interval from 7 to infinity, so from 7 to the right arrow, I went up again, which means that I am increasing. End behavior. So when we look at end behavior, we're paying attention to our left and right arrows. So the end behavior of a polynomial function is the behavior of the graph of f of x. Remember that f of x, another way to say that is our y values as x approaches positive or negative infinity. If you are looking left and right, you're looking at the ends of your graphs, the arrows. So the left arrow is what we are looking at for when x approaches negative infinity. And we are looking at the right arrow for when we're looking at x approaching infinity. If the arrow is pointing down, then f of x, or our y values, are approaching negative infinity, which means as the graph continues, our y values are getting more and more negative. If the arrow is pointing up, then f of x, or our y values, are approaching infinity, which means that as the graph continues, our y values are getting larger and larger. So let's identify what's happening with our end behaviors. So as x approaches negative infinity, so I look at the left arrow is pointing down, which means that our y values are getting more and more negative. So we are approaching negative infinity. As x approaches infinity, so the right arrow, this one is pointing up, meaning that our y values are getting bigger. So we are approaching infinity. For graph B, if I look at x approaching infinity, so x approaching negative infinity is the left arrow, which is pointing up. So as the graph continues, the y values get bigger, so we are approaching infinity for f of x. As x approaches positive infinity, so the right arrow is also pointing up, which means that we would approach infinity. The last graph, as x approaches negative infinity, so the left arrow is pointing down, which means f of x is approaching negative infinity. As x approaches infinity, the right arrow is also pointing down, so we're again approaching negative infinity. So remember, on a graph, you could have one approach positive infinity and one approach negative infinity, or you could have them both approaching the same type of infinity, positive or negative. Just depends on looking at your left and right arrows of a graph. Evaluating points and zeros of a graph. So given a graph, you can evaluate a function. When we are given a problem like f of x equals 2 with a blank, the number in parentheses is going to represent your x value. So on the graph, you find the x value, and then you look at the graph for the y value. That's what f of x equals. Remember that f of x represents your y value. A 0 is represented on the graph when it crosses the x-axis. So let's practice these two ideas. So in number 7, evaluate the function given a value. So it says f of negative 5. So I'm going to find my x value of negative 5, which is right here on the graph. The y value of the graph at that time is 0. When I look at f of negative 3, so here's negative 3, I go up to where the graph is, which is right here. The y value of that coordinate would be 5. Find f of 0. So here's 0, I'm going to go down to where my graph is this time, which means my y value is -5. And then f of 4. So here's 4 is my x value. Here's my graph that's along the x-axis. So my y value would be 0. How many zeros does the graph have? So a 0 is when it crosses the x-axis. So I have 1, 2, 3. So how many zeros does the graph have? 3. What are the values of the zeros? So what are the x-coordinates of my zeros? X equals -5, x equals -2, and x equals 4. So now we're going to put all those ideas together to look at a graph. So does the graph have a maximum, a minimum, both, or neither? So when I look at my graph, I notice that I have 2 higher points here and here, which are maximums, and I have 1 lower point here, which is a minimum, which in this case means then that I would have both. Is -6, 6 a maximum or a minimum? So if I look at -6 on my x-axis up to 6 here, this point right here would be a maximum because it's a higher point. So this would be a local max. Is 0, -2 a local min or a local max? So if I look at this point here, it's a lower point because here's 0 for my x. I go down to -2 for the y. This is a lower point, which would be then a local min. Is A a local max or min? So if I look at point A is a higher point that looks like a mountain, so it would be a local max. What are the coordinates of point A? So when I look at point A, the x coordinate that lines up with it is 5, and the y coordinate is 10. So this point would be 5, 10. Now we're going to look at increasing or decreasing along an interval. So the first interval is from -infinity, which is our left arrow, to -6. So if I look from -infinity to -6, I increased because I went up along my graph. So this would be an increasing function along this interval. My next interval is -6 to 0. So if I look at my next interval of -6 to 0 and I follow my graph, this time I went down along the graph, which means that I am decreasing. From 0 to 5. So if I look at the graph now from 0 to 5, here's 0 where I left off, up to 5. I went up along my graph, which means that I am increasing. And the last interval is from 5 to infinity. So 5 is where I left off at, and infinity is the left arrow, and along my graph I went down, which means that I am decreasing again. As x approaches -infinity, f of x is approaching. So when I look at the left arrow, because remember for -infinity, it's our left arrow. The left arrow is pointing down, which means that my y values, or f of x, is approaching -infinity as x approaches infinity. So now when I look at the right arrow is also pointing down, which means that I am approaching again -infinity. Find the value f of -8. So f of -8, here's -8 as my x-axis. On the x-axis, the graph is going through that point, which means my y value is 0. F of -6. So here's -6. Here's my graph. That y coordinate is equal to 6. So we would say the value is 6. F of 1. So 1 on the x-axis. Here's my graph passing through that point, which means the y value is 0. F of 5. Here's 5. When I go up to find my graph, the y coordinate there is 10. 22, how many zeros does the graph have? So when I look at zeros, zeros, remember, mean that it is crossing the x-axis. So I am crossing the x-axis once, twice, 3, 4 times. So I have 4 zeros. What are the values of the zero? So what are the x-coordinates? This one is -8, so x equals -8. X equals, the next one is -1. The third one is x equals 1. And then the fourth one is x equals 9.